So just a quick run through, a question like number 1, I would expect to show up in the multiple choice section of the exam. Number 2 could go either way. Number 2 is the kind of question that I might ask you to solve, or it might give you a system and a list of ordered pairs and say which of these is the solution. Something like number 3, I would expect to show up in the short answer section, the paper section. Number 4, similar to the bell work yesterday, I would kind of expect something like this to be similar to a bell work question that we had. Do you guys remember our bell work from yesterday where I had those 2 inequalities and you had to pick out which ones were solutions? And then we also had to give reasons. So it could be on the multiple choice portion, or it could be on the short answer portion where it said something like, here's the graph, pick out an ordered pair that is a solution, or is this one a solution, explain why or why not. Questions like these I would expect more in the multiple choice portion of the test. Writing rules that fit the data. If it's just from a table like this, that's more something that I would think of as a multiple choice question. Down here, you would need to write a rule here, but this is the kind of thing that I would expect to show up more on the paper portion, where I would need to see your work. This one could really go either way. If it was on paper, it would look very similar to this. If it was multiple choice, then it would be, pick out which are the proper equations for the graph g of x. Or is g of x showing exponential decay or exponential growth? How do you know? 12, 13, 14, those are ones that I would expect more like on paper. 15, with the way it's written, this is one that I might think, even though it's very similar to this one up here because it's not asking you to graph, it's asking you information about the graph, those tend to be good multiple choice questions. 16, probably paper. Same thing with 17. 18, I would expect that one to be more like a multiple choice. I'm thinking of the homework problems that you guys have had in the past, where you'll be given the equation and it'll ask you to select all that are true about the graph. 19, 20, I would think that would be more like a multiple choice style, but 21, I would think that would be more a paper. Show all your work. Any of the graphing problems where you have to draw the graph, I would expect on paper. So 22, I would expect to be on paper. 23, 24, 25, I would expect those to be more paper versus multiple choice. Simplifying and factoring, those strike me as things that would be more suited to multiple choice than questions like 28. So 26, 27, I would think that would be multiple choice. 28, 29, I'm thinking that would probably be more likely paper. Same thing for 30. 31 is already a multiple choice question, so I would expect something like this on the multiple choice section. 32, story problems almost always are going to end up on paper versus multiple choice. Asymptotes and removable discontinuities, there's usually a lot of work associated with these, and so I would expect something like this to show up on paper.
This one.
34, a question like this, I would expect this to show up on paper. A question like 35, I would think 35 is probably more a multiple choice style question. 36 is another one that I would expect probably more on the multiple choice because there's not really much work. It's how do you read the table. It's not any computation. So I would expect something like this to be multiple choice or one of those very easy fill in the blanks that would show up on the multiple choice Canvas portion where you like type in the numbers in the two blanks. 37 is a lot like 34. Very, very similar, so I would think this is probably more of a paper style question. $38, it could go either way, but because that 5-number summary is just things that we're grabbing from the graph, my natural leaning is this would probably be more of a multiple choice portion. Same kind of thing with 39. I would expect that to be multiple choice. 40 and 41, I would think that that's more on paper short answer style questions. What off the review would you guys like to see me go over? Yes, ma'am. Uh-huh.
On 36, or
$36 are which ones the same? B and E. Yeah, it is the same question twice. I would probably rewrite this one just for practice sake. I would probably rewrite this one and do it the other way around. Because if you flip it the other way around, it is different. Do you guys want to look at how those two would be different, even though they look very similar in notation? Okay. Part B, we already know that we're standing in front of the 50% off table. So I would only be looking right here. Every single number for part B would have to come from what I have highlighted in blue, because we're only talking about 50% off books. That's what that line says, given that, or I know that. I know it's a 50% off book. I want to know the probability that it is a hardback. How many hardback books are there on the 50% off table? 35. Out of how many books on the 50% off table total? 49. Contrasting that with part E, what comes after that vertical line? Hardback. So for part E, I'm not standing in front of the 50% off table. I've decided that I'm only going to walk out of the store with hardback books. I'm not going to purchase any paperbacks. So for part E, I'm only looking here in this red column. Only hardback books. We're not interested in buying paperback books at all. So the number of hardback books that are showing up on that 50% off table is still 35, so my numerator is the same. But now I'm not looking at the 50% off books. I'm looking at all the hardback books that there are. How many hardback books are there total? 75. So when we've got that vertical line, a given that, or I know this thing has happened, when you flip those two around and they change sides, my numerator doesn't change because it's still the intersection of those two things for my numerator. The denominator changes based on what I know. Does that make sense? Okay. What else would you guys like to look at or talk about? Number 4? Absolutely. Graphing the system of inequalities. top one is already written in slope-intercept form, so I'm going to go ahead and graph that one first. The y-intercept, the starting point is positive 2. And then it has a slope of 3, so I'm going to go up 1 and right 3. Up 1 and right 3. I can take that and turn it around as long as I reverse both directions. So I can go down 3, but then I have to go left 1. Run that to the edges of my graph. This does not have the or equal to underneath it.
Up 1 over 3, up 1 over 3.
Yep.
You did
It's up 3 over 1. Because remember, it's rise.
I was correct the first time, but you said up 1 over 3, and you got me confused.
Rise over run. So up 1 or up 3 over 1. I did it again.
Almost.
I did it again. Rise over run. Up 3, right 1. Yesterday on the bell work, we discussed we use the dashed line when it does not have the or equal to with it. That means any points that fall on this line would not be solutions. Even if it does end up in the red shaded space, if it's on the blue dashed line, it is not a solution. And then we would need to figure out which way to shade. To figure out which way to shade, I use a test point. My favorite test point to use is 0, 0. As long as my line doesn't go through that point, I can use it. So here's 0, 0. I'm going to substitute that into the inequality. And we're going to see if it gives me back something that is true. If I get a true statement back from that, then I will shade the side of the line where that point is. If I get back something that's false, then I will shade the opposite side of the line. So I'm going to put 0 in for y. I'm going to put 0 in for x. 3 times 0 is 0. So over here I have 0 plus 2. 0 is less than 2. Is that true? Yes. This is a true statement. And so I'm going to shade the side of the inequality where 0, 0 is. I need to make that bigger. So I would shade over here because this is the side where 0, 0 is at. To do the other inequality, the first thing I want to do is to put this in slope-intercept form. I need it in y equals form. So I'm going to subtract x from both sides. Negative 2y is less than or equal to negative x plus 6. Then I need to divide everybody by negative 2. That means both pieces over here, both numbers get divided by negative 2. So I have y is, what happens when we divide by negative? Yes, my inequality is going to switch directions, so it's not going to stay a less than. Now it's a greater than or equal to, because we are dividing by a negative. And then I have negative 1x divided by negative 2, so that's 1/2 x. Positive 6 divided by negative 2, so that is minus 3. So I start down here. Rise 1, run 2. I did it right this time. Rise 1, run 2 to the edge of the graph. Take it backwards. This one, because it does have the or equal to underneath it, it's got that little line. This one gets a solid line. And it means that any points that fall directly on here, as long as it's also in the blue shaded space, those would be solutions. I still need to figure out which way to shade. I'm going to use the same test point because 0, 0 is not on this line. So I'm going to use 0, 0 as my test point. So 0 in for y, greater than or equal to 1/2 times 0 minus 3 So I get 0 minus 3 over here. That's negative 3. Is 0 bigger than negative 3? Yes, that means I want to shade the side of the red inequality where 0, 0 is because it came back true. So that's going to be the top side here. And then they've asked me to determine of these 4 ordered pairs, which ones are solutions. 0, 2 is right here. Is that a solution? No.
Because it's on the dotted line.
Because it's on the dashed line. Anytime we are on a dashed line, it is not a solution. Cannot be. Let's see, 6, 0, right here. What do we think of that one?
Yes.
Yes. I'm going to give 2 reasons for that. Saying that it's on a solid line is not enough. Because if I were to put a point out here, this one out here is also on the solid line. But that one would not be a solution. Why? This one's not, but that one is. Yes, this one is also in the blue shaded space. So it's on a solid line and in the shaded space for the other inequality. To be a solution to the system, it has to work for both inequalities, and so I have to establish that it's working for both of those. If I say it's on a solid line, I'm only talking about one aspect of this. All right, -2, -4. -2, -4, right here.
I don't think that one works.
Why not?
Because it's also on a dashed line.
It's on a dashed line. On a dashed line, ever is enough to disqualify it. So no, I know it's where they cross, but that does not matter with inequalities. It's on a dashed line. All right, and then 4, 2. What do we think of that one?
In both shades.
Yes. Yes, it is in the double shaded space. All right. Is there anything else in particular that you guys would like to look at or talk about? Number 25? Yes, absolutely.
Suspense.
Number 25. Fantastic problem. We need to give these the same base so that we can solve for x. I'm looking at my 2 bases, 2 and 64. I want to figure out how to replace the larger one where it is written as a power of the smaller one. So the smaller one is 2. 2 to what power would give me this number 64? Because this is where I'm going to make my replacement. 2 to what power is 64? You said 2 to the... Is it 5th? I thought it was 6th. 6th? Okay, yeah. Good guess. 2 to the 6th equals 64. So I'm going to take this, since this is equal to 64, I can swap out things that have equal value. That is substitution. So 2 to the power of 6. This other side I'm just going to bring straight down. So that is equal to 2 to the power of 5x minus 7.
And don't both 2's cancel out?
The 2's now will cancel out, yes. When my bases are the same, I can ignore them moving forward. So I would have 5x minus 7 equals 6. And from here, I'm going to add 7 to both sides. 5x equals 13. Divide both sides by 5. You got x equals what? 2.6. X equals 2.6. Part B is similar, but on part A, only one of them had an exponent on it. On part B, they both do. Which one's bigger? 125 is bigger. So this is the one that I want to replace. The smaller one is 5. 5 to what power would give me something that has equal value with 125?
3.
Yeah, 5 to the third power equals 125. So I'm going to take this right here. This means the same as 125, so I'm going to let it take its place there. 5 to the third. I'm going to put parentheses around it because that 125 had an exponent of x minus 9 with it. I need to still include that.
But the 5's still cancel out.
The 5's are still going to cancel out.
Despite the other 5 being in parentheses, which usually doesn't mean canceling out.
You are correct. Notice I have a 3 here, and then I have this x minus 9. I'm going to need to distribute the 3 to the x minus 9. So when I have a power that's inside the parentheses and I have a power that's outside, I have to take what's inside and distribute it to what's outside. All right, so I'd have 2x equals 3x minus 27. I'm going to subtract 3x from both sides. What is 2x minus 3x? Negative 1x equals negative 27. When I divide both sides by negative 1, we get what?
Positive 27.
Positive 27. All right. We have 10 more minutes before the announcements bell comes on. That's enough time to do 1 or 2 more problems depending on how long or involved they are. What else would you guys like to look at? Which one? 34? Yes, absolutely. 34. Anytime you are entering a code to open up a lock, a safe, anything like that, the order that you touch the keypad, the order that you turn the dial in on your locker matters. So this is a permutation. The order matters. What is the total number of possible ways you can enter the 4 numbers to open this safe if there are no restrictions on the numbers that may be chosen? All right, so we're going to choose 4 numbers. The number of options get multiplied.
You have 9 options per
9 options for the first number. It says there's no restrictions, so if I wanted my code to be 1111, I could do that. Repeating digits is allowed if there's no restrictions. So if I have 9 options for the first digit, I have 9 options for the second, 9 for the third, and 9 for the fourth. I need somebody to grab their calculator for me because I do not know what 9 to the fourth is off the top of my head.
6,561.
6,561 different possible codes that could open this safe. Whatever brand of safe this is, if they have produced more than 6,500 some odd of these, there's 2 people out there that have chosen the same code. If no numbers are allowed to repeat in the code, now I've got to think through this slightly differently. I'm still going to multiply the number of choices I have together. How many options do we have for the first number?
9.
9. Then 8.
Then 6.
Then 7. Then 6. We can't go down further than that. This kind of situation right here, only the ones with no repeats. This is the one where we can use the permutation button on the calculator. If there are no restrictions, if I'm allowed to have repeating values, then even if it's a permutation, I don't use the permutation button. I only use that when I'm not allowed to have things repeat. What would this come out to be?
3,024.
3,024? Okay. Probability, this means I'm going to write a fraction. I can take my fraction and turn it into a decimal or turn it into a percent. But anytime they ask me to write a probability from a situation like this, I'm going to have to start with a fraction. The probability that the 4 numbers do not repeat. How many codes are there where they don't have repeating numbers? 3,024 codes that don't have any repeating values. Out of all the possible codes that exist, all the ones, even the ones that do repeat, 6,561. They asked us to write our answer as a percent, so what do I need to do with this? How am I going to take this and turn it into a percent? I need to divide it on my calculator. First thing I need to do is put it into decimal form. What would this be in decimal form? It's going to be a little bit less than
You want 100
0.5.
max?
Let's take it out to 3 decimal places.
So you want thousands.
Thousandths.
So 0.461.
0.461. How do I take it from being a decimal and turn it into a percent?
Times 100.
Times 100. So we're timesing it by 100%, which means this is what?
46.1%.
46.1%. So it's a reasonable guess. If you found somebody that had this particular type of safe, you're like, there's a pretty good chance that the code that you picked out, even though I don't know what it is, doesn't have repeating numbers. Still got about 4 minutes. What else would you guys like to look at? Let's go look at the very, very, very last one in the packet, number 41. And the reason I'm saying that is because this was one of the very last things that we talked about where we didn't have a test over this. This was just one of those little bits of statistics information that we talked about at the end. Mr. Inman wanted to do a survey to see how all Pike community members feel about changing the starting time of school to 8:30 a.m. To do this, he randomly generated emails sent to 500 students, staff members, parents, and other community members. What's the population that Mr. Inman is interested in? The Pike community. He's interested in all Pike community members. Who's the sample? Yes, this is our sample here. The 500 people that he actually sends the emails to, that he wants responses from. Students, staff, parents, and other community members. And then they ask us, when they say, is this biased, they're talking about the way the sample was picked.
No, it's not biased because it was randomly generated.
Yes. This is a situation, remember, if we say it's not biased, we're saying that it's a fair way to pick the sample. Everybody in the community had an equal chance of being able to share their opinion. Not everybody did get picked, but everybody had the same chance as everybody else. So is this bias? No. Everyone had an equal chance of being selected for the sample. One of the biggest points of confusion that tends to show up when we talk about choosing a sample and whether or not it's biased, students will often tell me that it's biased because not everybody did get selected. That's not what makes something biased. There is no way Mr. Inman has enough time to talk to every single student, parent, staff member, and anybody else that lives or works in Pike. But he's wanting to make sure that all possible voices have the chance to be heard. So with randomly selected emails going out, he's going to get some students, some parents, some staff members, some business owners, some people that live in the community and are retired. Everybody's, how would I phrase this? You might not be asked, but somebody that looks or thinks like you probably did get asked. So your views are being represented whether you actually got spoken to or not. That's what means it is unbiased or it's fair. All right. Guys, I don't know if you have noticed, but any of the days that I have taken requests, like yesterday, I have posted a video from both this class period and the other section of Algebra 2 that I teach. Any of the questions on the review that you have specific questions about, if I didn't go over them in here, check the video from the other class period because I took different questions in both classes. The answer key for the paper review will be going up in Canvas today. That will show all of my work. You can check your answers and your work against mine. It will go up today sometime after school. My goal is to have it up by 5, but I promise it will be up before I go to sleep so that you have the whole weekend with the answer key. And you have Monday since you don't take your exam until Tuesday. All right?